Hello and welcome to the Word of Genetics. The topic for today is prokaryote transcriptional regulation, and the type that will be discussed for today is positive inducible. Let's go over the meaning of positive and inducible. Positive is when an activator binds to DNA to help stimulate transcription. Inducible is when transcription is normally off and it is turned on when a small molecule is able to bind to a regulatory protein. Let's now talk about the lac operon. It is defined as a section of protein, but this particular section of protein contains structural genes, regulatory genes, and regulatory sites. Here, lactose is broken down into galactose and glucose with enzyme beta-galactosidase. Now, let's go over the different components that are part of this. You have the regulatory gene, which is LAC-I, and this helps code for the repressor. You have the promoter, which is LAC-P, and this helps bind the RNA polymerase to allow for transcription to occur. You have the operator, which is LAC-O, and this helps interact with the repressor. Then you have the structural genes, which are LAC-Z, LAC-Y, and LAC-A. And these are eventually transcribed and translated into proteins. For LAC-Z, this becomes beta-galactosidase, Y becomes permease, and A becomes transacetylase. Now I will show you the difference between a repressor and an inducer. For the genotype, it will be wild type, which is positive I, positive P, positive O, positive Z, positive Y, and positive A. And so for this particular example I showed you, like I said before, will be the repressor, which means that the operon is turned off and that lactose is absent. And so for this, I labeled it a spot for you to know what is going on at this location. And so for at 1, and you'll see that due to the absence of lactose, the regulator protein, which is considered a repressor in this situation, will then bind to the operator and it helps transcription to not occur in this particular scenario. Now, let's move on to where the lac operon has lactose present, and this will help the operon be induced and turned on. So the genotype will still be the same. And I did label this one as well with numbers so you can see in point by point what happens where. Point 2, due to the fact that there is lactose present, a percentage of the lactose is then converted into allolactose. The allolactose would then bind to the regulator protein at point 3, and this will make the protein inactive. Point 4, due to the regulator protein being inactive, this will cause the protein to not be able to bind to the operator. And at point 5, as you can see, this will cause the structural genes to be transcribed and translated. Now time for an analogy. So for this, look at the scenario. You need 2 things to fly, the plane and the pilot. The plane allows you to fly from one destination to another, but it cannot go anywhere unless the pilot is on board. In this scenario, the plane will be the activator, the pilot would be the effector, and transcription would be flying. Thank you so much for paying attention to my lessons, and I hope you come back for more. Thank you.